This is the Module 4 skills test about Newton's law of universal gravitation. And notice in the first little text box there is an equation that allows you to calculate the gravitational force between two objects, where the m's are the masses of the objects and the r is the separation between the two objects. When you get down to question 1, you're asked to compare the gravitational force of object A acting on object B compared to the force that B exerts on A. And notice that there are some numbers given. There's a mass of object A in arbitrary units. That means it could be pounds or kilograms or tons or whatever. You're also given the mass of object B, and you're given the separation between the two. And even though it seems kind of mathy, you really don't need the equation above. All you need to understand are Newton's laws of motion, particularly Newton's third law. So when you get to question 1, if you're in doubt, review Newton's third law to guide you. Now when you get down to question number 2, you're asked to rank the force of the moon acting on the spacecraft at various locations. And you're supposed to rank the force from least to greatest. This is where you will need that equation from above. You don't really need to crunch any numbers, but you need to understand the relationships. What happens when you increase the distance? What happens when you increase the mass? Etc., to rank these different locations. And again, you're going to rank them from least to greatest as far as the force that the moon exerts on the object. So you can rank choose the location, and then also choose less than or equal to as you rank them. And then finally, the last 3 questions are again asking sort of a similar thing, except for number 3 you're asked about the gravitational force of the Earth on the spacecraft. Where's that going to be strongest? And number 4, where's the gravitational force by the moon on the spacecraft going to be the strongest? You will have already sort of answered that in question number 2. And then finally, in question 5, you're asked to figure out when the spacecraft is exactly halfway in between. Let's see right there. What's the gravitational force on the spacecraft exerted by the Earth, and then what's the force of the moon on the spacecraft, and then if you added those together, what would the net gravitational force on the spacecraft be?